Week 4. Guidelines and Models. Additional notes. Cognitive modeling. Definition: a theory that produces a computational model of how people perform tasks and solve problems by using psychological principles and empirical studies. Cognitive modeling. Research methods: formal analysis, philosophy, logic, linguistics, mathematics, computer science, programming techniques, artificial intelligence, empirical methods, experimental psychology, neuroscience. Modeling. Role: limits the design space, answers specific design decisions, estimates total task time, estimates training time, identifies complex, error-prone stages of the design, a means of testing current psychological theories. Human Information Processor, HIP. External world. Human Information Processor. Receptors. Perception. Processor. Memory. Processor. Effectors. Motor actions. External world. Cognitive modeling. Applications. GOMS. Today's presentation. SAW. Integrated Architecture for Knowledge-Based Problem Solving, Learning and Interacting with External Environments. ACTAR. Atomic Components of Thoughts. Rationale. GOMS. Overview. Formal representation of routine cognitive skill. A description of knowledge required by an expert user to perform a specific task. Provides a description of what the user must learn. GOMS. Classification. Provides a predictive, descriptive and prescriptive model. Predictive. Predicts the time it will take user to perform the tasks under analysis. Descriptive. Represents the way a user performs tasks on a system. Prescriptive. Guides the development of training programs and help systems. GOMS definition. GOMS models users' behavior in terms of goals, what the user wants to do, operators, specific steps a user is able to take and assigned a specific execution time, methods, well-learned sequences of sub-goals and operators that can accomplish a goal, selection rules, guidelines for deciding between multiple methods. GOMS. A family of models. Keystroke level model. KLM. Card. Moran. And Newell. CPM-GOMS. natural GOMS language, and NGOMSL, Cognitive-Perceptual-Motor GOMS, CPM-GOMS. GOMS, Keystroke Level Model. KLM. Simplest GOMS technique, the basis for all other GOMS techniques, predicts execution time. Requires analysts applied methods. Assumes that routine cognitive skills can be decomposed into a serial sequence of basic cognitive operations and the motor activities, which are K, a keystroke, 280 millisecond, M, a single mental operator, 1350 millisecond, P, pointing to a target on a small display, 1100 millisecond, H, moving hands from the keyboard to a mouse, 400 millisecond. GOMS, Card, Moran, and Newell. CPM-GOMS. Subgoal invocations and the method selection are predicted by the model given the task situation. In program form, analysis is general and executable. Predicts operator sequence and execution time. Based directly on the model human processor. Extending GOMS, grammars. Explicitly represent knowledge a user needs to translate from goals to actions. Task action grammar, tag, by Payne and Green. Model of content knowledge rather than a full system to generate user performance estimation. However, we can measure by number of rules. Extending GOMS. Production systems. Like grammars but models a goal stack and working memory. Tedious to write but can be fed into a program to automatically check for completeness and accuracy. Can predict errors and learning time behavior. Extending GOMS, learning. How to estimate time to learn. One solution, SAW, UMIC. From the FAQ. SAW has also been used for modeling learning in many of these tasks. However, learning adds significant complexity to the structuring of the task. Extending GOMS natural GOMS language. NGOMSL. Structured natural language notation. Based directly on the cognitive complexity theory. Eras and Paulson. Allows GOMS to model working memory, WM, and set up sub-goals. Unlike CPM-GOMS, provides quantitative predictions about time to learn each new piece of a task. Extending GOMS, parallel processes. Cognitive processes are not always sequential. Clerks imprinting checks often realize an error 2 checks passed. When typing, you often realize an error while typing the next sentence or letters. Extending GOMS. Cognitive-Perceptual-Motor CPM-GOMS predicts a substantially shorter execution time than the other models, allocates less time for prepare for action type operations, allow parallel processes, requires analysts applied methods, uses critical path analysis to investigate parallel processes. Further readings. 1. Human-Computer Interaction, 2006, by Seringal Smith Atterton, Thompson. 2. Interaction Design, Beyond Human-Computer Interaction 4th edition, by Jenny Pressey, Helen Sharp and Yvonne Rogers. 3. Designing the User Interface, Strategies for Effective Human-Computer Interaction, 5th edition, by Ben Schneiderman, Christine Pleasant and Stephen Jacobs. Further readings. 4. Human-Computer Interaction, 3rd edition, Alan Dix, Janet T. Finley, Gregory D. Aboud, Russell Beal. 5. Usability Engineering Jacob Nielsen. Many of Nielsen's other usability books, Designing Web Usability, Eye-Tracking Web Usability, etc., are available for free from Safari Books for free from on campus. You can also find great information, excerpts and reports at useeit.com. 6. The Design of Everyday Things, Donald A. Norman, a classic book on design, not limited to computers or technology.